Today's lesson is going to look at Chapter 23, Section D, on counting with combinations. Remember from the previous section that if I want to find all the permutations of 5 symbols taken 3 at a time, I can set up a series of 3 boxes. Each box represents how many options I have for those permutations. In the first place, I'm going to have 5 choices. In the second place, I'm going to have 4 choices. And in the last place, I'll have 3 choices. Well, 5 times 4 times 3 is going to give me 60 different permutations. I've taken the time to write out all of these permutations. Here they are. Now, I've ordered them in such a way that in each column, you'll notice there are only 3 letters used. For instance, in the first column, I only use the letters A, B, and C. In the second column, I only use the letters A, B, and D. If I were to take just the top permutations in each column, I would have taken what we call only the combinations of these letters. The combinations are taken without regard to order. So if I count up the number of columns, I see that there are 10 combinations. Versus the 60 permutations that I've had. What this would look like in the real world is if I'm going to select a team of 3 people from 5 total people, right? If the order doesn't really matter here, if I have Johnny, Jen, and Jess, that's the same combination as Jess, John, and Johnny. There's no difference there, so I don't need to distinguish between the different permutations. Therefore, I'm only interested in the combinations. And again, combinations are really permutations without regard to order. So how many different ways, distinct ways, can I group a set of people or symbols? So let's take a look at a couple definitions. Right, the definition of a combination is a selection of objects without regard to order. So again, in the previous example, A, B, and C, A, and B are the same combination. They're different permutations, but they're the same combination. Now, there are several different symbols that we can use, or several different notations that we can use to denote combinations. There, in fact, are 3. And in all 3, we're taking a look at 2 numbers. N, which is the number of distinct symbols that I have, and R, which is the number of symbols that are taken at a time. So the 3 ways that I can write a combination are like so. C, the next one of N, and then a subscript of R. Or I can write the N first, and then the C, and then the R. Or I can use just parentheses with N over R. Again, N is the number of total symbols. And R is the number of symbols taken. I'll show you an example of how this works in just a second. But let's define the equation in terms of factorial notation. Again, something that we looked at in the last section. because now we can put it into mathematical terms. So I'm going to use the first notation, the one with the superscripts and the subscripts. I'm going to write the general equation for the number of combinations. And it is n factorial over r factorial times n minus r factorial. Let me show you an example of how this works. On the first page, we saw that there were 60 permutations for the letters A, B, C, D, and E. But if I only took taken three at a time, however, there were only 10 combinations. So in this case, 60 So in this case, n is equal to 5, and r is equal to 3. Remember, I have 5 total symbols, but I'm only taking 3 at a time. Put into the equation, we have this notation, and we have 5 factorial over 3 factorial times 5 minus 3 factorial, which is just 2 factorial. Doing a little bit of math here, we can see that 5 factorial is 100, 3 factorial is 6, and 2 factorial is 2. So we have 120 divided by 12, which equals 10. And this is the number of combinations, distinct combinations that we have. Let's look at another example. And I'm going to show you in this example how to use your calculator as a shortcut. But you should know how to use the equation on its own without the calculator for quizzes and tests. So the question is, how many different teams of 3 can be selected from a squad of 8 if there are no restrictions? So in section A, we're going to set up our combination notation. I need to know what n is. N is 8, and r is 3. So I can write the appropriate notation, and then the equation. 8 factorial over 3 factorial over 8 minus 3 factorial, which is going to be 5 factorial. If you want to take the time to do this in an expanded form, 8 times 7 times 6 times 3, you'll notice that 8 factorial is 40,320. 3 factorial is again 6, and 5 factorial is again 20. If you simplify this, you'll see that there are 56 different combinations of 3 people selected from 8. Let me show you a shortcut in your calculator. First, you need to find out what n and r are for your problem. In your calculator, you're going to type in n. So in this case, we would type in 8. Then you go to the Math button. And within the Math button, you're going to choose the PRB menu for probability. And within that menu, you're going to choose the third option, which is NCR. You'll notice that's one of the notations that we use for combinations. Hit that button, and NCR appears on your calculator. And then you want to type in R, which in this case is 3. If you do that, your calculator will spit out 56, which saves you a little bit of work. But again, you should know how to use both methods for a quiz or a test. All right, so that's the first part. The second part, now we're restricting the combinations in a certain way. We're saying that the team captain has to be included. So instead of picking any 3 people, we have to include the captain, and then we can choose any of the other 2 remaining people. So, how many different ways can you pick a captain? Well, let's assume that there's only one captain of the team, so there's only one total possibility. I'm going to choose that person, so this is a combination of 1. If you were to do this in your calculator, you would see that this expression equals 1, so it's really not going to matter. It will later in different examples. But we're going to multiply that by the number of remaining combinations. So the remaining choices for the team are out of 7 people, and I'm going to choose 2 of them. Using our calculator, I can do combinations twice. I'm going to have 1 NCR1 times 7 NCR2. If you plug this into your calculator, you'll see that there are 21 different ways to select a team of 3 from 8 people where we have to choose the captain. Let's look at one more example, and hopefully that previous problem will make a little bit more sense. Now we have an equestrian team. There are 7 males and 6 female riders, and we're going to choose only 4 of them. So in part A, there are no restrictions. In other words, I could have a team of all males, a team of all females, and any combination in between. I want to find the number of combinations, again, because we're talking about people. I'm not worried about all the different permutations. So let's find just the number of combinations. So using our notation, n, the total number of people is 7 plus 6, so 13 to choose from, and I'm going to choose or take 4 of those at a time. So I have C with the 13 in the superscript and a 4 in the subscript. Using my calculator, I'm going to punch in 13 NCR, again from the math menu, 4. And that's going to get me 715 different combinations. A lot of different combinations. Just to show you what that would look like in equation form, one more time, that would be 13 factorial over 4 factorial times 13 minus 4 factorial, which is 9 factorial. So again, you should be able to do these types of problems both ways. Let's take a look at part B. Now I'm going to add some restrictions. So there must be at least 2 of each sex. So I need 2 males and 2 females. Really, I'm going to do 2 different combinations here. I need to split it up into 2 different combinations so that the total number of males is 7, and I'm going to take 2 of them, and the total number of females is 6, and I'm also going to take 2 of them. The way to calculate the total number of combinations is using the product principle. So I'm going to set up the expression like so. C with a 7 in the superscript and a 2 in the subscript times C with a 6 in the superscript and a 2 in the subscript. Again, using my calculator, that's going to be C NCR2 times 6 NCR2. And this is going to equal 315 combinations. So, as we would expect, there are fewer combinations because I'm putting restrictions on who can be on the team. The last example problem gets slightly more complicated because I have to think about more than two different combinations or pairs for the team. And in the previous example, we used the product principle. Here we're going to use the product principle and the sum principle. So the restriction now is that there must be at least one of each sex on the team. Well, how many different ways can we represent that? I could have 3 males and 1 female. I could have 2 males and 2 females. Or I could have 1 male and 3 females. I can't have 4 of each because then each one of the sexes wouldn't be represented. I'm going to split these up. I'm going to add these different combinations using the sum principle. I need to use the product principle to find out each individual combination. So using combination notation here, I have 7 total males. I can choose 3 of them for the first scenario. And I have 6 total females, and I can choose 1 of them for the first scenario. The second scenario we've already done. It was part B. I can choose 2 of 7 males and 2 of 6 females. And the last one, I can choose 1 of 7 males and 3 of 6 females. And so really at this point, this becomes a plug-and-chug problem where we're going to plug these combinations into our calculator. You could do it by hand, but it would take a little bit of time. So I suggest you use your graphing calculator. So using our calculator, we can find the combinations for each of these expressions. The first expression, C 7 over 3, would be 35. The second one would be 6. And then I would get 21 times 15. You should do this, by the way, to ensure that you're getting the right answers and using the right method. And then the last combination would be 7 times 20. This is 210 plus 315 plus 140. That's going to get you a total of 665 permutations. Again, we'll do more example problems or practice problems in class tomorrow.